One of you asked the question, how do we make plasmas in a lab, and is it expensive? And is it doable by a regular human being, is the way I read that question. Well, let's chat about it. Hello, my name is Greg Friedman. I'm a bioengineer who spent most of his career on working with plasmas for medical, environmental, and other types of applications. So let's take a look at the question. How do you guys usually generate your plasmas in the lab, in the research you know of? I have never generated plasmas before. I mean, what does the equipment usually consist of? Do you simply drive some custom or off-the-shelf type of boards with a good supply? Or are these complex and highly engineered pieces of equipment that would cost tens or hundreds of thousands of dollars? Fantastic question. Fabulous question. So how can we make plasmas? Well, radiation, light, high voltage, and kinetic are the ways I'm thinking of right now. So let's analyze each one of them individually. Radiation. So you can have, what is plasma? Plasma is an ionized gas. You ionize that gas by breaking down the molecules in that gas. How can you do that? You can have a source of radiation emitting high energy particles colliding with molecules of air, for example, breaking them down and ionizing air, creating plasma. How do you do this? You buy a radiation source. How much are those? I don't know. Never bought one. I am not certified, and certified is where it gets expensive. So radiation is a fairly well-studied, well-understood phenomena, and everyone knows that it is not safe. So safety and occupational health considerations are the expensive part of this operation. I would go with probably many hundreds of thousands of dollars that would go into the facility to make sure the walls absorb any radiation, to make sure that all the workers or students have the right radiation protection, regular training. So that part, the radiation source itself, isn't going to be that expensive, and that's not very difficult to set up those experiments, but the facility itself could be quite expensive. What's the other way of making plasma? Again, plasma is an ionized gas. You can ionize it by focusing laser beam, one or a couple of laser beams, focus them on a spot, and high energy photons will begin ionizing the gas and ionizing the metal that you're focusing your laser on. So you create lots of heat from that plasma, and you can use it to cut metal or plastic or wood or whatever is it that you're trying to achieve. Is it relatively easy to do? Yes, you buy an off-the-shelf laser source. There are many available in multiple power ranges. You can buy a 10-watt laser that could scorch, has enough energy to create really weak, very tiny plasma, enough to, cut paper or etch metal, making nice little pretty patterns. If you go up in power, and those lasers are hundreds of dollars. You can go higher in power, go to fiber lasers. Those are thousands of dollars, 3, 5, 7, maybe 10, and up from there. And you can have very powerful lasers that can create enough power to create plasma that's powerful enough to melt through an inch of steel. So you can have a nice laser cutter for under 100,000. It all here with lasers, they are a very well developed, relatively old technology that is pretty readily available off the shelf. Can you make those components yourself? You can. You can read literature that's decades old, figure out how lasers are made, and make one from scratch, but it's pretty challenging. If I were building a laser-based plasma system today, I would get the laser components off the shelf. They're pretty perfect and really readily available from many, many vendors. So Kinetic, I'm sticking to the obvious high voltage one to the end. You can smash things together. So you can take a molecule and a molecule, accelerate them to insane velocities and smash them together so electrons fly away and the molecules are now ionized. Those are called particle colliders. Are they possible? Yes. So they're used to study really weird plasma conditions. You study individual particles and these Higgs bosons and that kind of stuff. Can you build accelerator at home? A very ghetto one, yeah. But real accelerators are billions of dollars to make plasmas by smashing things together. But you can. That's the important part, right? You take a speckle of sand, accelerate it to as close to speed of light as you can, and smash it to a piece of lead. Can you do that? Yes. Is it expensive? Yeah. You want to decrease resistance of the medium that your speckle is traveling through, so you need vacuum pumps. And vacuum pumps are able to pump out large volumes of air from large tubes will be very expensive, millions of dollars, billions of dollars in case of modern heavy particle colliders. So can you do it at home? Not really. What's the cost to build it? Gosh, infinite. But you would start with a few $100,000 to study small effects, and you get into billions to study more interesting stuff. And I saved high voltage for last. So you can generate plasmas by applying high voltage between two electrodes. You take a positive and negative, or positive and ground, or negative and ground. You take two electrodes and you create high potential difference, high voltage difference between them. You need, for ionizing air, you need roughly 32,000 volts per centimeter. So if your electrodes are 1 centimeter apart, your power supply needs to deliver 32,000 volts for the initial breakdown to occur. How do you get 32,000 volts? Well, you take 110 or 220 from the wall, you put it on one side of the transformer, you put it in a coil, and then you have the second coil with more windings. So if the ratio between the low voltage coil and a high voltage coil, if the ratio of the number of turns of the coil is, let's say, 10, then you multiply your voltage by 10 and you drop your current by 10, so the power remains constant. So if you put in 100 volts and your multiplier is 10x, you get 1,000 volts on the output, and you need 32,000 for 1 centimeter. So your ratio, if your input voltage is 100 volts, your turns ratio, so-called turns ratio of your transformer, needs to be close to 1,000x, right? So you put in 100 times 1,000, you have 100,000 volts on the output. Well, it's overkill for 1 centimeter, but it's perfect for 3 centimeters, just over an inch. So if you want your arc to be an inch long, the turns ratio of your transformer needs to be 1,000 times. You're going to lose 1,000 times of current to keep the same power. So if your input is 1 ampere, then your output at 1,000 turns ratio, your output is 1 milliampere. So that the spark that you will create will have 1 milliampere of current. If that's enough for your application, that's great. Can you do this at home and with cheap parts? Yeah. You get a magnetic core, pennies. Pennies for magnetic cores, you can wind copper wire by hand, connect to 110, and you'll have 60 hertz, 100,000 volts on the output. Now, when you push this high voltage signal into your system, the system pushes back. So you need to build in overcurrent protection. You need to build in a lot of stuff. So while the first step of making plasma using high voltage is very straightforward, it quickly becomes more and more challenging. Plasma systems power supplies available today on Amazon.com. I see them as cheap as a couple of bucks. The trade-off there is your power and your energy efficiency. So for a $3 Amazon.com power supply made in China, I would expect efficiency to be on the order of 10%, which means 90% of the energy you put in gets lost in heat. Do you care? For a lab experiment that you're doing once, I don't think you do. So if you want to study what a spark does to your mushroom growing environment, well, get the $3 Amazon thing and experiment with that. The fact that its energy efficiency is 10%, what do you give a shit? It doesn't matter. Now, when you start getting into industry, you start noticing your electricity bill. So you're losing 90% of your investment in electricity just to heat. So you might want to increase efficiency. How do you increase efficiency? You increase complexity of your pulse generator. So the power supply that I'm working with, its efficiency, and we're very proud of it when the power supply is properly matched to the circuit, to the plasma you're trying to generate. Our efficiency can be as high as 80%, which means 20% is still completely wasted. Industrial systems that cost millions of dollars, they're matching your power supply to your load. That's what it's called, matching, and there's a matching network. Very expensive microelectronic components that dynamically sense the load and respond to it. That part can be many millions of dollars. Is it important to you? Well, are you running $1 billion operation where saving a few bucks on the electric bill translates into half the price for the iPhone that you're trying to make? This power matching stuff is really important for microelectronics industry that's using plasma on a daily basis for making microchips. Very important for them to save energy per chip because they're making billions of these chips. It's also important for big industry where plasma is used for melting stuff. The less energy the plasma requires, the cheaper your output material becomes and the more competitive you are on the market. And these are old technologies, relatively speaking. They're decades old, so there's been a lot of competition. So when you're talking about working in a lab, we can get away with low energy efficiencies and run our experiments disregarding cost of electricity. When we start moving into industrial applications, your question becomes very important. And analysis, cost analysis, and CAPEX and OPEX, so capital expense for your equipment and operating expense for your equipment, all those questions are very, very important, and they're important down the line. So I hope I answered your simple question with more details than you care to hear, but the devil here is in the details. Can you make plasmas using radiation, light, kinetic, or high voltage? Yeah, you can. Can you do it easily in the lab and cheaply? Yeah, in most cases you can. Can you do it easily, cheaply, and quickly in the industry? Not competitively. No. So that's the focus of my daily research, is how to make these systems more efficient. And that's where interesting questions are. Anyway, thank you for asking the question. If you have any more questions like this, please ask them in the comment section below. Or if you have any other science question, I'm happy to attempt to answer them. Peace. I'll see you in the next video.